Welcome to my channel, Dr. Munshi Nasser Skeleton. How are you, my dear learners? We are continuing the Florian Hayes Using R for Introductory Econometrics book, chapter by chapter. We are now in chapter 3 and we have covered quite a few things in my previous videos. Now we are covering multiple regression analysis estimation. And as you know, in previous videos we have discussed univariate regression, where there is only one regressor and one dependent variable. In this particular video, we are talking about multiple regression analysis in practice. So let's get started and we will explain everything, and as you know, how to run the R syntax and R scripts using the R Studio. First two videos it discussed about the R Studio, how to load the packages, how to command the different code. Okay, all these things already covered in my first few videos, so you know how to do these things using R Studio. Now we are going to cover the conceptual part of this book, especially the using the R syntax. Of course, we will refer to R syntax. I recommend you to use this R syntax type in your R Studio so that you can practice R at the same time you can learn econometrics slowly and gradually. And remember, my dear learners, this is an introductory econometrics class, so of course we are not going to go deep into the matter. We will go slowly and gradually in the upcoming play videos. Now, multiple regression in practice. So as you know, multiple regression meaning that there will be more regressors. So here, instead of one x1 or one regressor, we have x2, x3 and k number of regressors. That's what it says. And it's a very similar kind of regression analysis using the LM function, which we have covered in our first few videos, the LM command. And using the summary command, you can get your coefficients, residuals and all other important informations of the regression analysis. So that's what it says in the first few paragraphs. And then we go to the determinants of a college GPA as an example. This book is very good because it gives you a lot of examples from the Aldrich Introductory Econometrics book, and I strongly recommend you to practice these examples. It is predominantly using R programming, but it has another book called the Python programming, as well as if you wish to use any other software, of course you can do that, like Blue Sky, JAPS, any other softwares, no problem. But I would suggest that use R as your basic analytics tool, so that in the future if you want to become a data analyst, R will be a more useful tools for you. Okay, and therefore there is a script, like for example, as I said, how to run the script in my previous videos. First few videos I already demonstrated using R Studio. This is also no exception. First you load the data first, and then of course library package, meaning the Aldrich package, you need to upload it in the R programming platform environment, and then you command this using data, the data set, and then GPA1 data and the package Aldrich. Follow just exactly the same scripts and you will get the output in your R Studio platform. So no need to worry about how to run it, because everything is given in the book. Okay, and the book link is already in my description box. You can download the book and practice by yourself using this video as a part of your conceptual understanding. Now here it gives you the LM command and run the regression using college GPA as a dependent variable, and then you have two highest GPA and the SET results as your independent variables, and then you have your data set, and this is how it gives you the results. Okay, and you see the relationship are positive relationship, the coefficient, intercept, all are positive relationship, so we can understand that college GPA is positively related to your high school GPA as well as your SET score. So high school GPA and SET score has a positive impact on the college GPA, as well as you can see that 45% of the high school GPA, if 1% change in the high school GPA, 45% chances that you will be higher GPA in college GPA. Same goes to SET. If 1% change in your SET score, it will impact almost 9% of your college GPA results. So that's what it says, and of course the results will gives you minimum, median, quantile information. Same goes to the standard error t value, p value, and here in the p value you can see the star marks. It means that what is your significance level, whether it is a 5% or 1% significance level, and that's what it says, that what is your significance level. Of course it gives you standard error t value. You can calculate it using standard error and t values, but by looking at the p value you can easily say that the intercept is highly significant. Then high school GPA is also highly significant, however the SET score is not highly significant. because it is not fall under 5% or 1% significance level, and that's what it says. Also, it gives you the multiple R square, which is 17%. In my opinion, this model is not that good, because only 17% of the model is explained by the three variables: college GPA, ACT, and high school GPA. So therefore there are many other variables which we did not cover in this model. That's why the R score is very low. Therefore we should say that it's a weak model. And F statistics also good in terms of the p value, that's what we are looking at, but not that good to say that it's a very good model. Okay, the closer to the significance level, which means 5%, less than 5% or 1%, then you should say that yes, it's a very good model according to the F statistics p value. Okay, now there are some examples, and I already explained you log model in my previous video, and how to convert your non-linear model to a linear model, and that's what one of the example it gives you. And by giving the summary command, you will get all this information in R programming using RStudio, all the regression commands and everything. Okay, and there is another example. There are a lot of examples. I should say you should use this book for your practice, because a lot of examples are given and same examples coming repeatedly. So this will help you to understand the basic idea how to run the regression using multiple regressions. One of the important thing, OLS in matrix form, and in here it says the chronological way of how to use the matrix form, and we need to use transpose, matrix multiplication, and inverse matrix command in R programming in order to show it as a matrix form. And in more detail you can go and check the Aldrich book, but here it gives how you can command using the R programming like this command to get it in a matrix form, the results. Okay, sometimes we need it, but often we don't need it, and it's not necessary to understand the matrix form, but just for the sake of your understanding, here is an example, and I would recommend you how to do that. In the first video we have discussed the how to use a matrix command so that you can convert your whole thing into matrix. It is very easy. First you create the data, and then you have n row, how many rows, and then you have this first independent variable calling the value variable, and then you bind this dependent variable and your independent variable, and then you will have a matrix form like head x command. And this is how you can use the estimation of the parameters, okay, residuals and all that. So there is another thing that called the ceteris paribus interpolation and omitted variable bias. Omitted variable bias, the reason why we're discussing about this, because you see in the last discussion we said the lower R square value, which means 17% R square, meaning that the model is not good fit. So what happened, actually it happened, the most of the variables, the important variables, we may missed out, we did not add it to this particular model, and therefore R square value is not higher. Okay, it is not closer to 100%. So therefore we should say that omitted variable bias is very important, and in order to get a good model, there is two way you should remember. One is called the forward selection method, the other one is called the backward selection method. Okay, what is forward selection and backward selection? Let's assume that you have a bunch of independent variables, and you do not know what to leave and what to add in your model. So you start adding from like forward selection, meaning that you need to add one by one, okay, and see how the R square value is changing. Okay, and backward selection meaning that you reduce one by one, and already added the independent variables, you reduce one by one and then find that how the R square value is changing. So that's what, if the R square value is improving, which means the addition of your variables may causing this, and therefore you should consider those variables. Sometimes what happens, there could be a multicollinearity problem, meaning that the two explanatory variables or two regressors are correlated. That case, the omitted variable bias might give you a problem, and that we will discuss in the next video as well. But for this video's sake, you need to remember, in order to check your model whether it is a good or bad model in the cross-sectional analysis using OLS model, I recommend you to use forward and backward selection method, as well as we will check the multicollinearity problem and then heteroscedasticity problem in the long run, in the next video. So we will discuss those things very easily, and that's what it says here as well in more detail. And I believe this is what you should see, like using some variables and then cutting these variables taking only one variables at a time and looking at the intercept and the coefficient value and the r square value. This is how it says, and there is some way it has been written here. Okay, the relation shows to the given sample. Okay, and it's difficult to include all relevant regression, making a omitted variable a pre-relevant problem. It is important enough to motivate a vast amount of methodological and applied research. You need to know what are those important variables before you run any regression. Okay, more advanced techniques like instrumental variables. For instance, we said that if the assumption 4, which means 0 conditional mean, if it is violated, then there is an endogeneity problem, and you might find the instrumental variable is a handy way to solve the problem, and that's what it says. Okay, now the important one here is called the multicollinearity problem, and by looking at the variance inflection factor, we can easily find the multicollinearity problem. The variance inflection factor, if this is the null hypothesis, is there is no multicollinearity, and if the significance comes, the variable, we cannot reject the null hypothesis. If the variable, if the hypothesis comes not significant, then we should accept the null hypothesis. The variance covariance matrix is also given here, and there are some technical issues which of course it makes this variance inflection factor accounts for imperfect multicollinearity problem, which means the two regressors or the two explanatory variables are correlated, and we can find out by using the variance inflection point, and it is very easy to give the command, and this is the command, variance inflection point command, VIF command in the R programming, and this is how you can find out the value. The standard way of finding out, the first run the regression, then summary the regression, this is the object, this is the regression, and then find your variance inflection point value. Okay, and remember it says it is in the R car package, so you need to install the car package, and then this command library car, you need to do the library every time you install a new package. Do a library so that this package will call by the R studio, and you can use it for every time you open the R studio. You just have to library the package. Among other useful tools, this package implement the command VIF, okay, for linear regression model. And as I told you, variance inflection factor, it is indicating that if the value p value comes what do you call it, the p value is insignificant, then we should say that there is no multicollinearity problem. But if there is a significant value, then there we should say that yes, there is some problem in the multicollinearity problem, and that's what it says. You see the variance inflection point values. Okay, and how there are some explanation of course here given for your better understanding. Okay, so for this video, I guess this is what we have, and in order to run the automatically calculate the VIF, the coefficient, this is LR, the model that you run, this model LMRES, this is the object LMRES object, and you run this and you find the points. Okay, none of these points are significant, I mean these are not preliminary dominated, so it means that the multicollinearity problem does not exist here. Okay, does not exist here. Okay, so this is what it says. We extend the example regression using log wage on education, potential overall experience, the number of years, the current employee. We could imagine that these three variables are correlated with each other, but the results show no big VIF. You see, we could imagine that these three variables are correlated with each other, which is the multicollinearity, but the results show no big VIF. If the VIF is big enough, then we should say yes, there is a correlation. But if the results doesn't show that much big enough results, in other words the p value is not significant, then you should say there is no big VIF. The largest one is for the coefficient expert, and its variance is higher than by factor only 1.478, then in a world in which it were uncorrelated with other regressors, so we don't have to worry about multicollinearity here. So the conclusion here is, so we don't have to worry about multicollinearity here, and the value gives here 1.11, 1.4, 1.3. So the larger the VIF value, there is a higher chance of multicollinearity. The lesser the VIF value, which means closer to 0 then or closer to 1, then you should say that yes, there is no multicollinearity problem in your model. But larger the value, let's say more than 2, okay, or 2 more than 2 or 2 or 2 more than 2, in that case you should say and you should worry about multicollinearity problem. Otherwise, if less than 2 or close to 0 or 1.11 or 1.4, something like that, you should not worry about multicollinearity or the correlation between the regressors in your model. So I hope you understand today's discussion about the multicollinearity and use of VIF. We will discuss more information in the next video about the next chapter. Until then, bye bye.